Yeah. So what we discussed in the previous class, guys. So we discussed about the S3, right? Sunny, did you
Yes,
watch
sir.
the recording?
Yes, sir. We discussed about S3, sir.
Yeah. So did we done the task, guys? You guys have done the task that replication and the what is that? The other concept, lifecycle management. So did you watch any video on YouTube or Google?
No, sir.
No, no.
Actually, I got fever on Thursday, sir,
Hmm.
and
So
I
today is Monday,
recorded.
right?
Yes, sir.
Yeah. So what we are discussing about today we are discussing about. So today we are discussing about the Docker, guys. What is a Docker? Guys, does anyone knows what is a Docker?
I don't know, sir.
Sunny, Avinash,
No, sir.
Avinash. No, right? So what is a Docker? So you don't know, right? Now you understood. So, so this is a DC, guys. What this is? This is a DC or a, the other name is, what is the other name for the DC, guys? What is DC? Forgot,
On
guys.
premises.
On premise.
On premises.
So on-premise environment, DC data center or on-premise environment. So in the on-premise environment, so what we did, guys, they are providing only the IaaS, right? Infrastructure as a service. So this is the physical. So innovative thoughts comes into the picture. Then what is the gut, guys? So innovative thought comes into the picture. So this is the physical. After physical, so after physical, what came, guys? What came? Virtualization, right? So this is the physical server and this is the virtualization, right, guys? This is a virtualization. If you install the virtualization OSA, virtual software on on our physical server, so we can install the number of OSs, right? So for example, CentOS 7 you installed, CentOS 7, Red Hat 7, Red Hat 7, Ubuntu, Oracle Linux. So Oracle Linux 7, Ubuntu 8, sorry, Ubuntu 16 or 20. So Ubuntu 16. So these are the virtualization concept, guys. The same concept will be available under the cloud also. Cloud also same, right, guys? So what they are providing? They are providing a
All three.
so they are providing the all three the same concept, right?
Yes,
They
sir.
are also providing the virtualization, physical and virtualization, right? So if you want a physical dedicated server, they will give physical dedicated server. If you want a instance, EC2 instance, you can create a EC2 instance, right? But here, guys, please concentrate here. So for example, these two are in the production servers. So this is in the uh, so these two are QA. So this is the a dev, guys. This is a dev server. Guys, please assume this is the prod. So this is a QA. So this is a dev environment, guys. So this is a dev environment. So this is a virtualization OVM Oracle virtual machine installed on this server. guys, a Oracle virtual machine is installed on the servers. I want to deploy application. I want to deploy application. What we need to do? What we need, guys? Guys, what we need? So we install the CentOS 7 virtual machine. Okay, this is a CentOS 7 OS, and so we install the. Guys, tell me what we need to install. For example, install Java, install
Tomcat.
Tomcat, right? Our application is in the our application is in the Tomcat, right? You created the code through the Tomcat server. Then you deployed in the Tomcat server your code, something like a facebook.var char, right? This is the dev. The same will be on the need to install Java and install Tomcat. So here also we need to install Java, install Tomcat. So here also, so we need to install the Java, need to install the Tomcat. So here also we need to install Java, install Tomcat. For example, here Java is 1.8, 1.8, and Tomcat is 9. Tomcat is 9. Here Java is 1.6, 1.6. Tomcat is 8. The same here also 1.6 and Java is 8. So here Tom Java is 1.5. So Tomcat 7. So 1.5 Tomcat 7. So in these all the versions are same or a different, guys?
Different, sir.
So different versions. So you deployed the code. For example, you wrote the code in the which language, guys? Java 1.8. Java 1.8 version. You deployed the code in the Java 1.8. The code will be, sorry. So you wrote the code in the Java version 1.8.
1.5.
1.8. Wrote the code. Wrote the code. This is our code, guys. So which version you which through which language which Java version you used and write the code, used the 1.8, write the code, right? The Tomcat, you deployed the Tomcat 9, and it is working fine for the in the 1.8 and 9 version. So you try to deploy it on the QA, right? So this is the QA. So QA is a 1.6, Tomcat is 8. It may be a support, it may support or it may not support, right? There might be a issue with the infra, something like a pass, right? So here also, because of the version to version, it might be a functional changes, it might be a some conditional functions changes, right? So the code will be might be it working in the different versions. So sometimes something like a Java, these guys is deployed a version with the 1.8 and Tomcat 9, and the build version is something like a Facebook jar. This Facebook jar that is deployed under the version of 1.8. It might be work or it might not be work in the the below version. So something like in the the versions 1.5, 1.6, and 1.8. Right. So this is the issue. So this is the issue, and we need to install if you want to deploy on the code. Definitely we need to install Java Tomcat, install Java Tomcat, install Java Tomcat, right? So this is the the process is headache, and so we need to install based on this. Here we need to install the CentOS 7, CentOS 7, CentOS 7, CentOS 7. So right, this is the guest OS. So in the hypervisor there is a OS called as a OVM or a VMware, right? You here you install the two OSs, right? That might be a confusion. So is there any alternative solution? Yeah. So the innovation from physical to innovation thoughts comes into the picture. Virtualization came into the picture, right? So innovation and the virtualization comes into the picture. So there is a innovation from physical to virtualization called as a containerization. So what it is, guys? Containerization. So what it is? Containerization. So containerization is nothing but yeah. So listen, guys. So you installed a one physical server. So installed a one physical server with CentOS 7, physical or VM, whatever it may be, guys. So this is the CentOS 7. On top of CentOS 7, you install the Docker container. What is that, guys? Docker container. What you installed? You installed the Docker container, Docker service. So once you install the Docker service, we can run the number of Dockers. So we can run the number of containers. So we can run the number of containers. So this is the container. This is the container. This is the container. This is the container. So we can run the number of containers based on the based on the resources. Based on the resources. For example, this is your this is your virtualization, right? For example. So these two are related to QA. These two are related to pre-prod. These related to dev environment, right? But for this resources, so we need to, so at a time we need to start the two Docker containers, So if you want to use the QA, you need to shut down the pre-prod and dev. So you can start these two containers. So once done the QA, you can shut down this and you can start the pre-prod. You can start the pre-prod. Guys, understand? So a big innovation task comes into the picture and created as a containerization. What is this, guys? So guys, what is that?
Containerization.
Containerization.
Uh, so Docker containerization. So Docker containerization. So what it is, guys? First, initially, it starts with the physical. So it starts with the physical, then virtualization. Now, what comes into the picture, guys?
Containerization.
Very good. What is that? Contain.
Sir, what was the issue in virtualization?
What is the?
What was the issue they came
So
up
not.
with? What containerization?
Yeah. So containerization is right. So here, what is the resources, guys? So the resources is something like here CPU 20 CPU, RAM 64 GB or 128 GB, and HDD is 2 TB. 2 TB, right? So for the cost cutting purpose, they introduced a virtualization. So in the virtualization, so we need a 1 CPU, RAM 2 GB,
20 GB.
so hard disk 20 GB is enough, right? So 20 GB enough. Now you see, so now you see
Lot of difference.
the difference is lot of difference. 90% of the, so if you install the virtualization, so the 90% of the cost cutting, the cost we can save, we can reduce the cost. So from virtualization to containerization, so within 1 GB you can run your container. So within 1 GB you can run your container with code, softwares, platform, and OS. You see, guys, so this is your container. So this container contains our code, OS, and platform. OS and platform. If you run the Docker service, so we can run as a microservices. The microservices concept. So microservices concept comes into the So microservice concept comes into the picture. Now you understood, guys? So a containerization, so within 1 GB, within, so the size of the container is below 1 MB, below 1 GB. Guys, now you understood? So the cost reduces, innovative thoughts comes into the picture from physical to virtualization. So virtualization to containerization. So what is the benefit of the containerization? So here, right, there is a there might be a compatibility issue. There might be a compatibility issue. So right, so everything, Java, Tomcat, code, and OS, everything will be in the container. You just deploy it on the VM. You just deploy it on the physical server. Nothing to be installed. So nothing to be install. So here, so we need to install Tomcat on each and every environment, each and every server, right? So if we create as a container, we don't need to create on this. We don't want this burden on the physical servers or a virtual servers. So everything will be in the container. You just run the container. Now you understood? I will tell you guys, no worries, no worries. So this is just a example or a overview. So I will tell you everything. Okay. Yeah, Docker. Now you understood, right? Just Docker. Docker is a containerization concept. So from physical to virtualization, so virtualization to containerization. So containerization is nothing but we can segregate so we can deploy our application as a microservices, and so within the 1 MB we can run our applications, and so in the one container, so one VM we can run multiple containers. We can run multiple containers, guys. Docker, Kubernetes plus Jenkins. Docker, Kubernetes plus Jenkins. This is the most important topic, guys. Okay. So prerequisite basics of Linux, basics of AWS. So course content part 1 Docker, part 2 Kubernetes, part 3 Jenkins. So what we will discuss, guys? We will discuss a Docker, then Kubernetes, then Jenkins. Okay. So Docker application deployment stack. So what is the stack we need, guys? HTML content and templates, CSS style sheets, client-side JavaScript including frameworks such as Angular or React, build tools such as Maven or Gradle, web server such as Apache. So server-side runtimes and frameworks including Node.js, PHP, Python, Ruby, .NET, Java, databases such as MySQL, MariaDB, SQL, MongoDB, other services for catching messaging queues, Redis, Kafka, Git, and GitHub source control. We need these guys, right? So setting up the development stack. Setting up the development stack. So this is our application. Our front-end components, backends, so DB, environment libraries, everything, the servers. We need these guys for setting up the development stack. So issues with the development stack setup. Issues with the development stack setup. This code does not work worked on my system because of worked on my system because of so she is running on the 1.8, but he is running on the 1.6, right? So there might be issue with the versions. There might be a issue with the versions. So you use a Mac OS, they use a Windows OS. So you developed the app using the Java 1.8, they have Java 11 installed. You used the MongoDB 3.6, they are using the 4.2 MongoDB, right? So there is a version mismatch, and so whenever he verified this code doesn't work. So whenever she verified, well it worked on my system. So here, so how we can resolve it? How we can resolve it? Virtualization. So virtualization here, guest OS something like a OVM, Oracle Virtual Machine, or a VMware software. Then your guest OS is CentOS, so CentOS 7, CentOS 7. Here we already install one OS and you install the get OS, guest OS something like CentOS 7, CentOS 7, and you need to install the binaries and libraries, binaries Java, JDK, and binaries libraries. Then we can deploy our application, right? So in the VMs, we already installed a one hypervisor, OS, host OS, then guest OS, then deploy the application. Advantage, multiple OS in the same mission, yes. Easy maintenance and recovery, yes. Lower total cost of ownership, yes. Disadvantage, multiple VMs lead to unstable performance. Hypervisors are not as an efficient as a host OS. Long boot up process. Long boot up process. So containerization. So the containerization technique, you containers. So host OS. What is the host OS? CentOS 7 is installed. Container engine, Docker container engine you run. So directly you can run the app and bins library. You can run the app and bins library, Advantages over the virtualization. Containers on the same OS kernel are lighter and smarter. So better resource utilization compared to VMs. Short boot up process. Short, so it's a 1 by 20th of second. So 1 by 20th of second. So VM versus Docker. So VM versus Docker. So the virtual machine size is something like a elephant. The Docker container size is something like a rabbit. It works like as a tortoise slowly, and the it's okay as a leopard or cheetah. So something like integration. So we can integrate easily, we cannot integrate easily. So containerization. So containerization, this is the containerization. So Docker provides the, who provides the Docker container solution? So initially Docker provides the container solution. So this is the a trademark or logo of the Docker container. So working on every system, something like working on my system, mine too, because of you created a Docker and deploy it on anywhere. So what is a Docker? Docker is a platform of packaging, deploying, and running the application. So what is that, guys? Docker is a platform for packaging, deploying, and running applications. Docker enables you to separate your application from your infrastructure so you can deliver software quickly. Docker enables you to separate your applications from your infrastructure so you can deliver software quickly. Docker packages a software into standardized units called as a containers. Docker packages Docker packages software into standardized units called as a containers. Docker packages software into standard units called as a container that have everything the software needs to run, including the library, system tools, code, and runtime. So by taking advantage of the Docker's methodology for shipping, testing, and deploying code quickly. What is that? Shipping, testing, and deploying code quickly. You can significantly reduce the delay between the writing code and running it in the production. So Docker architecture, Docker file, through the Docker file, we can build the Docker image. So from the Docker image, we can run the container, Docker container. So Docker file, we can build the Docker image. From the Docker image, we can run the Docker container. So Docker terminology. So Docker file, Docker image, Docker hub, Docker registry, Docker client, Docker container. Guys, everyone can speak out. So what are the Docker terminology, guys?
Docker file, Docker
Ah,
image, Docker hub, Docker
mm,
registry, Docker
mm,
client, Docker
mm,
container.
mm. So what is the architecture? So the
Architecture
architecture
is a
is
Docker file and they
mm,
build
mm,
Docker image and
mm.
run the Docker container.
This is your application. Your application is finally deployed on the container. So from the Docker file, first we need to build the Docker images. We need to build the Docker images. From the Docker images, we can run the container. So in this container, our application is deployed. Okay.
Okay, sir.
Yeah, Docker complete architecture. So Docker client, in the Docker client, what are the commands you can run? Docker build, Docker pull, Docker run. So Docker Build is nothing but to build the Docker images. Pull is nothing but so to pull the Docker images. Docker run is nothing but run the Docker containers. So Docker daemon. So here the containers are running from the image. So you push it to the registry. So what it is a registry. So what it is a registry. Yeah. So Docker build, Docker pull, Docker run, and so this is the Docker daemon and the Docker registry. Yeah. So registry, what registry you know, guys? So what is the registry? Remote registry, remote repository. What you know? Git, right? You know the Git, right? GitHub, Git pull, GitHub, GitLab, and Bitbucket. So what you can do in the what you can do in the Docker Hub. So hub is a repository. What did you guys? Hub is nothing but a repository. Hub is nothing but a Docker repository. So Docker repository contains the Docker repository contains the Docker images. Right? This is the a Docker hub. What did you guys? It is a Docker hub, Docker hub or Docker registry. Everything is same. Docker hub or Docker registry. So in this Docker registry, so what it has? It has a public repo and a private repositories. Public and private registry. Public and private. So private registry repository. So so what it contains? It contains the Docker images. Repository contains a Docker images. A repository contains a Docker images. So so from the Docker build, right? From the Docker build, you can build the so from the Docker build, you can build the from the Docker build, you can build the Docker images, right? Yeah. So you have a Docker file, right? From the Docker build, once you build the Docker, it creates the Docker images. It creates the Docker images. So if you want to pull this Docker image, so if you want to pull this Docker image to, so if you want to pull this Docker images, Yeah. So if you want to pull these Docker images to, so Docker images to Docker repository. So from the Docker repository to you can pull, you can from push. So with here, so git push, git push. So we can push the, Docker images. So from your Docker from here to, so in the repository. So from Docker pull, so you can use the Docker pull. What is that, guys? What is the command? Docker pull command. Pull is nothing but a downloading. Sorry, here Docker pull, right? Sorry, guys. Docker pull. So under Docker push. What is that, guys? Docker push. Is my mind is here or not there? So Docker pull and Docker push. So once Docker pull, right, pull the repository, push the repository, push the images to the Docker Hub, Docker repository, then pull it to your Docker container. So Docker container by using Docker pull and nginx, Docker push and nginx, it will push you to the your account. So for example, I will show you. Think Docker push. You see hub.docker.com. So here, this is the Docker Hub registry. So this is the Docker Hub registry. Yeah. So you see, guys, so I pushed the images. So this is my repository. So my Tomcat 9, my first image, my Tomcat 9. You see, guys, so I pushed these images to my private, my public, my repository. What is my repository? My repository is a Hare Krishna 857. Guys, now you understood? So I push it and pull this from here to there. So once we push it, so it can pull to any environment, right, guys? It can pull any environment. So for example, I am pulling these images. Yeah, I'm pulling these images. So these are the Docker Hub images, right? So whatever the image you want, so you can push it in the you can push it in the dev environment, you can push it in the QA environment, you can push it in the production environment. So for example, dev, QA, and production environment. So prod environment. Now you understand. So if you create the one image, if you create the one container, one Docker images, so you can run on the multiple Docker containers, something like a in the dev environment, QA environment, and production environment, and it is a compatible. It will be compatible. The resource compatibility, guys. Now you understood, and it created as a, a microservices. A container is nothing but a microservice. Docker container is a microservice. Microservices. So what is microservices? Now I will tell you. So this is your WhatsApp website. This contains a. So this contains, guys, tell me. Chat. So this is chat. So this is chat. Status. So this is chat status, chat status and contacts. So these three run as a container as a microservice. Microservice. So microservices. So before everything will be in one a virtual machine. Everything will be deployed under the one virtual machine. If something goes wrong on the anyone, if something goes wrong, everything will be deployed under the one virtual machine, right? So this code will be deployed under the one virtual machine. If something goes wrong on this a virtual machine, everything collapse, right? But nowadays, if something goes wrong on the chat, so the status will work and the contacts will work. So the only issue with the chat, so we can check it and we can resolve the issue immediately, right, guys? So microservices, Docker concept is nothing but a microservices environment. Microservice environment. Guys, understood? Guys, so microservice environment. So what is the terminology, guys? Docker file, Docker image, Docker hub, Docker registry, Docker client, Docker container. Guys, now you understood?
Yes, sir.
Yeah. So what are the Docker commands? So Docker we can version of the Docker info, it will check the info, Docker help, Docker login, right? So we want to get the code from the repository to your local machine. So right, for how you are authenticate with your good GitHub to the GitHub to the remote repository. Sorry, GitHub, Git Bitbucket or GitLab from your local. So we generated a token, right? Last time we generated a token and we log in, right? The same way we need to, if you want to pull the code or if you want to pull the image or push the image, definitely Docker image, we need a authentication, right? So definitely we need a Docker login. Docker image is nothing but how many images are there. Docker PS is nothing but a process state. So Docker pull is nothing but a image ID. We can pull the image ID from the a public repository or our own repository. So Docker run image ID, we run as a container. Docker build the image. Docker tag, we can create the tags. So Docker push is nothing but we can push from your local to the GitHub remote repository, Docker Hub repository, Docker RMI, remove the images, Docker RM container ID, remove the containers. So application development. So collection of program is called as a software project. Software project contains several components. So front-end components, user interface logic, back-end components, business logic, and database components, persistence logic. In order to deploy our application in the mission, so we need to set up all the software which are required to our application, are required to run our applications, right? For example, OS we need to install, Java install, MySQL install, MySQL DB install, Tomcat web server 10.0, etc. we need to install, right? The real-time project should be deployed into multiple environments for the testing purpose. For example, I already told you, right? Dev environment, set environment, UAT, pilot, and prod environment. So WhatsApp application. So so you have a UI, web components, business component, persistent components, and database. So front end we need to connect to back end we need to connect to the database, right? So front end we use HTML, CSS, Bootstrap, Angular jQuery. Back end we install the Java 1.8, Spring Boot, Hibernate. So right. So DevOps people deploying application in the multiple environments. DevOps people deploying the application in the multiple environments. For example, in our Git repository, we have a code. So DevOps people took that code and so in the DevOps development environment, right? Linux plus Java plus Spring Boot MySQL, Linux plus Java plus Spring Boot plus MySQL, Linux plus Java plus Spring Boot plus MySQL. So pilot environment, Linux plus Java plus Spring Boot plus MySQL, Linux Java pod environment for Linux Java Spring Boot plus MySQL environment. We need to deploy these, right? So dev environment will be used by the developers to perform the integration testing. Set environment will be used by the testing team to test the functionality of the application. UAT environment will be used by the client to test the functionality of the application. Pilot environments, pre-production environment. Pod is nothing. Pod means live environments. It is used to the deliver the project. To deploy application, to these many environments, we need to take off all the softwares required to run our application in all the environments. it is very difficult task, right? The virtualization. So what is the virtualization? Virtualization, installing the multiple guest operating systems in one host operating system. Hypervisor software will be used to achieve this. We need to install all the softwares in the host OS and run OS application. So it is a old technique to run the applications. System performance will be slow in this process. Slow in this process to overcome the problems of virtualization. To overcome these problems of the virtualization, we are going for the containerization concept. So containerization. So what is a containerization? It is used to package all the softwares and application code in one container for the execution. It is used to package all the softwares and application code in all the softwares and application code in one container for the execution. Container will be take care of everything which is required to run our application. So we can run the containers on the multiple machines easily. So the Docker is a containerization software using Docker. So we'll create the container for our application. Using Docker, we will create image for our application. Docker image we can safely easily to multiple machines. So using Docker image, we can create the Docker container and we can execute it. So we can create a Docker container. We can execute it. What is the conclusion? Docker is a container session software. What is that, guys? Docker is a containerization software. So Docker will take care of the application dependencies for the execution. Deployments into multiple environments will become easy if we use the Docker container as a concept because of a container. Right, Docker installation. How you can install the Docker? So install Docker Amazon Linux, install sudo yum update -y, yum install Docker -y. So Docker start. So add user to the Docker group by existing the below command is sudo user mod -az Docker 2. Right. So we can use how you can install the Docker. We'll show you guys. No worries. Docker commands. What is a Docker? Docker installation in Linux. Docker architecture. Docker commands. Guys, understood? So from the Docker file, we can build the Docker. From the Docker image, so you can run the Docker container. So you can push it to the Docker hub. Okay, understood? So whatever the image you created, right, last night, that image you can push it to the your manager. Your manager will will your manager will push that port to the repository registry. Okay, what is the Docker installation in Linux architecture? Docker commands. So Docker terminology. So Docker commands, Docker info, Docker images, so Docker pull, Docker run, Docker ps. So Docker terminology, Docker file, Docker image, Docker container, Docker registry, Docker engine. ఇన్ని కోర్సులు వచ్చినాయి అన్నమాట. So yeah, so Docker terminology, Docker file, Docker image, Docker container, Docker registry, Docker engine. So Docker file contains the instruction to create an image. It contains Docker domain specific keywords to build image. Docker image is a package which contains everything, app code, softwares and libraries and everything. Docker container is a runtime instance of a Docker image Docker image out. So out application will execute the Docker container. Docker registry is a place where we can store our Docker images. Docker engine is a software using which we will create Docker images under Docker containers. So Docker Hub is a public repository. Everybody can store and retrieve the data images. Nexus, JFrog, DTR, AWS CR are the private repositories. Are the private repositories. Docker Hub is a public repository. Everybody can store and retrieve the images. Nexus, JFrog, DTR, AWS, ECR are a private registries. So we need to purchase it. If you want to push your images to the repository. So in the real time, most of the cases they are using the Nexus repository, Nexus and JFrog repository. Guys, understood? So tomorrow we will install the you install the service. So install HTTPD, right? The same way we can install the Docker service and we can run the Docker service and we can create the first we need to build from the Docker Hub. How to create the Docker Hub? How to sign up the Docker Hub registry? Yeah, guys. The task is you guys can sign up with your Docker Hub registry account. Okay. So before you guys create a Docker Hub account, just sign up, guys. You guys can sign up with your Gmail. So tomorrow we will pull the images from the Docker Hub and push the images through the Docker Hub from local to Docker Hub. Guys, understood?
Yes, sir.
Yeah, guys. So we'll continue from tomorrow. Okay? Guys, understood? Sunny, Avinash, Pavan.
Yes, sir.
Okay? Yep. Thank you, guys.